Good morning. ഇന്ന് നമ്മൾ ഡിസ്കസ് ചെയ്യാൻ പോകുന്നത് ബൈനറി സെർച്ച് ആണ്. ഓക്കെ, സോ ദിസ് ഇസ് എ കോഡ് ഫോർ ബൈനറി സെർച്ച്. സോ ലീനിയർ സെർച്ച് ഓൾറെഡി നമ്മൾ ഡിസ്കസ് ചെയ്തതാണ്. സോ ബൈനറി സെർച്ചിൻ്റെ കേസിനകത്ത് വി വിൽ ഫൈൻഡ് ദ മിഡിൽ എലമെൻറ്റ്. ഇഫ് ദ മിഡിൽ എലമെൻറ്റ് ഈസ് ഈക്വൽ ടു ദ കീ ആണെങ്കിൽ ദെൻ വി വിൽ റിട്ടേൺ ഇറ്റ്സ് എലമെൻറ്റ്. Otherwise we have two options. Either middle value is greater than the key, then we only want to search the left side, so then high will be moved to the left side, array size will be decreased to the left sides. Similarly, opposite, if middle is less than k, then low will be moved to the right. So what it do is that if we have 100 elements initially, first we will consider 100 elements. Then what we do is that we will go to the middle position, and if the element is there in the middle position, we will stop there. Otherwise we will check whether the element is less than the middle element or greater than the middle element. If the element is less than the middle element, we will consider only the first 50 elements. If it is greater than the middle element, then we will consider the last 50 elements. So it will be going like that. So initially, if we have n elements, so in the second phase we will consider only n by 2 elements. Third phase we will consider only n by 4 elements. Like that it will be going. So time complexity will be log n. So best case time complexity of binary search will be 1, and the worst case time complexity will be log n. We have a condition for performing binary search because the list should be sorted. That's the basic condition for binary search. So today, we will discuss this algorithm. So I have taken the linear search code and I am going to modify that. Okay, so small changes we only want to do. So instead of linear search, I am going to write binary search. So array is there, size and k is there, all the things same. So this is a binary search code. We will implement the binary search code. The same code we will write. We can just copy the algorithm itself. Only thing is we just want to add some. Okay. Some components we will change that according to the C syntax. So initially, what do you want? We have an array. Array which array is a size, and s is the size of the array, and k is the element to be searched. I'm going to declare this variable as int low equal to 0, then high equal to s minus 1. So I will put a semicolon here. Then it starts from the while loop low is less than or equal to high. Then we will have a curly bracket. Okay, inside that I am going to set middle is equal to log plus high by 2. So if a of middle equal to key, then it will return true. Else it's check whether it is greater than middle element is greater than the key. Then we only want to check the left side. So high will be moved to the middle minus 1. Otherwise we have option of low is equal to. So we have to put semicolon. Semicolon will be put here, this line also, this line also, and instead of end of while we will put a curly bracket. Curly bracket is being placed. If the statement is not working, then it will terminate, and if it is terminating, then it is returning 0. So the same algorithm, the same program we have implemented for binary search. So it's very simple to convert an algorithm to program. Just want to copy that, and because we are not writing the pure algorithm, we are using the pseudocode. So we just want to convert like this. So we have the array. Array is being read by the user. It's read. Then we input the element to be searched. And instead of binary search, I want to call the linear search. Binary search. Flag equal to 1. Element found, otherwise element not found. So this is the basic code, provided the input value should be in sorted order. That's the basic requirement. So I will just save that. Binary search dot c. So this is the code. We want to compile that. We will take the command prompt cmd, and we will go to the desktop. Desktop, we have the TS folder is there. I'm going to compile that. So I have the BinarySearch.c code. Okay. Middle is not declared, so while converting you have to declare the variables. So I will declare middle here as middle. So don't declare anything inside the loops because it will be repeating. So that's the thing we have to consider. Then so I'm just compiling. Compile it and want to input the value. Enter the size of the array. I'm entering as 5. Enter the elements. Here we should be careful. The value should be entered in a sorted order. So I'm going to enter values as 1, 2, 3, 4, 5. So I want to search the element 3, element found. So this is a common way, but we cannot give a burden to the user that he should enter the value in a sorted order. We cannot say like that. So what we can do is that user will be working in the same pattern. User can enter any values, but the program should do that. So what we can do is that before executing the BinarySearch program, we have the bubble sort program here. So we will copy that bubble sort function. So this is a bubble sort function. We will just copy this bubble sort function, and I will place it here. After the BinarySearch, I will just okay. So before the BinarySearch function, first I will write the bubble sort code. So bubble sort code is being placed. So if I pass a value to a bubble sort array, it will sort the elements. So I just want to pass before starting the program BinarySearch, I will be calling bubble sort. Bubble sort I'm going to call. I will be passing the array and the size of that. So what it do is that it will go to this code and sort the list, and after sorting the list, the element will be searched, and it will give the result. So user don't know whether we declared the element to be sorted or not. So in this way we create the illusion that user can enter any value and perform the operation. So we will run this code again. So the code is missing. We'll check that. Here I missed. Bracket is missed. Okay. So size of the element 5, and I want to enter some values 1, 3, 6, 8, 9. So I want to search the element 6. So element found. If I'm giving some other values, so 5, element to be searched, I am going to use some values 3, 6, 8, 1, 0. So element to be searched 11. So it's not terminating. We will check that. So this loop is not terminating. Right, it's not terminating. We will check that. Middle is equal to log plus height by 2 if middle equal to. We'll put as low as sample. Compile it again. 5 elements. 6, 7, 1, 5, 9. So element to be searched is suppose 1. Element found. If I will give another value option. If I is less than high, middle equal to low plus high by 2, high by 2, then A of middle value is being checked. If it is equal to 0, then it will return 1, otherwise A of middle is greater than key, then high will be moved to middle minus 1 and low will be moved to middle plus 1. Then just look at it everything. We will check the code. So in this case what we can do is we will do some, this type of errors will come. So in order to solve this problem, what we can do is that we will just print the status of the array. First of all, we want to trace the code. Okay. So how to trace the code? So I have the sorted array. I just want to print the sorted array. First of all, I will see whether the print statement is working or not. Printf. Instead of and, I will put a. So I will see whether the code is been executing. Low is s minus 1, middle, all the values have been set. So it is going to an infinite loop. Low is less than high. So that's what we want to check. Let's execute the code again. And giving values 1, 0, 3, 6, 7. Element to be searched is 8, 0, 1, 3, 6, 7. So the list is in sorted. So it's not terminating. Why it is not terminating? We will check that. So initially the low will be 0 and high will be 0, 1, 2, 3, 4. So it's 4, then it will come to here, 0 plus 4 by 2. So it will, we will look like a bracket here. Low plus high by 2. We will put this one also like this. I will compile that. 5 elements, 1, 6, 8, 3, 2, 3. Element to be searched is 9. So element not found. So that's the problem. The problem was that this one. So we identified the problem that we have not put a curly bracket here, low plus high by 2. So that statement is not being executed directly. So this is low is less than or equal to high is okay. So we will check the condition again. We will run one more time. This is the code. We'll take the code. We'll execute the code. 5 elements. Then we will give some values 1, 8, 6, 0, 9. So I want to search the elements 11. So it's showing 11 not found. So we will sort of fail with it. Okay. So this is the final code. We will compile it once more. So I will be compiling the code and I want to execute the code. So 5 elements are given, 1, 8, 0, 4, 6. Element to be searched, I want to enter as 9. So it's showing element not found, and if I give an element to be found, element 1, 9, 11, 16, 4. So I want to search the element 16, element found. So in this way we can do binary search. So important thing is that how to convert. The main thing is that how to convert the code. If you write a pseudocode, we can easily convert that to the original code. And user should not feel whether the list. We don't want to give extra burden to the user. All the work we have to do. User is working the similar pattern as the linear search itself. Thank you.